All right, one more thing to talk about when we're looking at proportional reasoning is scale drawings. So scale drawings are you taking something and either drawing a smaller um, kind of map of them or design of them, or drawing a bigger one. So for houses, it's usually a smaller plan, and then maybe for like small objects, we blow them up so there's a scale there that is increasing. So the scale is just the ratio that we use. So for example, 1 inch on a drawing might mean 30 miles in real life. So that would be looking at like a map. Okay, and so how we use scale drawings or scales for drawings, we're gonna set them up just like proportional ratios, and then solve for the unknown. So we've got this sailboat, and it tells us here at the bottom that the ratio is 1 centimeter to 5 meter or 1.5 meters. Okay, so then we're going to use this ratio as it's going to be proportional to the ratio of any length on the drawing to the actual size. So right here, if the boat is 3 centimeters on paper, what is the boat's actual size? So 3 centimeters over the actual size. So 1 centimeter is equal to 1.5 meters. So we set up our ratios like that. And now we can use cross product. So 1 times x is just going to be x. That's going to be equal to 1.5 times 3. Okay, so we don't need to do anything with the x because we already have x by itself. And x is equal to 4.5. So 1.5 times 3. And this would be in meters. So now in real life, if that's 3 inches, then its actual dimension is going to be 4.5 meters. Okay, so we're setting up the ratios, making sure to keep the drawing dimensions as our numerator and actual dimensions as our denominator. And if you flip those, that's fine as long as you are consistent. The actual on top and the drawing dimensions on the bottom. Okay, so now we've got the mast on the boat is 10 centimeters tall. So I'm going to first write my ratio of my scale, and I'm going to set that equal to, okay, it says 10 centimeters tall, and that's on the drawing. So drawings on top is our numerator, and then actual dimension is our denominator. So to find what it is in real life, we take the cross product. Once again, 1 times x is going to be just x. And then on the other side, we have 10 times 1.5. So x is going to equal 15 meters. Okay, once again, use the cross product here and then solve for x. And we get x equals 15 meters in real life. Okay, now this next one, we're going to kind of work a little bit backwards. We're given the actual dimension and what it shows in the drawing, and we've got to find the scale. So we've got the model train. We're told that it is 609 inches. And then it shows right here that it is 7 inches in the drawing, or in the model size. So we know that 7 over 609 is going to be equal to 1 over x. Okay, so we're looking for just what 1 inch is equivalent to in real life. So the unit rate is pretty much what the scale is. And so now that we have that, we can take the cross product and we will get 7x is equal to 609. Now last step, divide by the coefficient. Coefficient is the number in front of the variable. X equals, and 7 can go into 68 times with a remainder of 4. So then 7 can go into 49. 7 times, and that would give us our bottom of our scale. So the scale of this is for every 1 inch, it is equal to 87 inches in real life. Okay, so once again, we know that scale is always going to usually be 1, 2, unless it tells us different, but when we're trying to find what the scale is, just make the top number 1 and then find for actual dimensions. Okay, the length of a room in an architectural drawing is 10 inches. Its actual size is 15 feet. What is the scale of the drawing? Okay, so once again, we're given the dimension and the actual dimension, and we're trying to find scale. So we can set it up once again. So this is 10 inches over 15 feet. So our drawing over our actual. And we're going to set that equal to the scale, which is going to be 1 inch over x. So now we're trying to find what 1 inch correlates to. For actual dimensions, we've got our proportional relationship. Take the cross product. 10 times x is equal to 15 times 1. This is just going to be 10x is equal to 15. Divide by 10. And x is equal to 1.5. And it's important to note that this is feet. So 1 inch to 1.5 feet. So then our scale is 1 inch to 1.5 feet. Okay, so the two ways we're given the scale, and we've got to find the actual dimension of a part based on how much, or based on its actual length in the drawing. Or else we're given the length of the drawing to its actual dimension, and we got to find the scale. So now we've done that. Last one, just kind of story problem, thinking of maps. So if a scale on a map is 2 centimeters is equivalent to 9.5 kilometers, what is the actual distance between two cities that are 5 centimeters apart? Okay, so we can set up our proportional ratios. We know that it's 5 centimeters on the drawing or on the map. And so once again, my numerators are going to stay the same as in refer to the drawings. And then the actual is going to be below. So take cross product, and we've got 2x is equal to 5 times 9.5. It's going to be 2x is equal to 5 times 9 is 45 plus 5 times 0.5. That's going to be another 2.5. So that would be 47.5. Last step, divide both sides by the coefficient. That is the number in front of the variable. We're left with x here. That's going to equal half of 4 is 2. And then half of 7, would be 3.5. And half of 0.5 is going to be 25, so then that would be 23.75 kilometers apart. And that's using scale drawings. We use the scale as one of our ratios, and then we set that equal to the dimension over the actual, and we can either solve for scale or solve for dimension based or actual dimension. And that's scale drawings and maps.